Hello, so today we're going to be looking at exothermic and endothermic reactions. The first bit that we'll cover in this is the conservation of energy in chemical reactions. So what I mean by that is that in a chemical reaction, energy is always conserved. So conservation of energy in chemical reactions. So what we need to know is that energy is always conserved. So you don't lose it and you don't gain any in a chemical reaction. So let's write that down. Energy is conserved in a chemical reaction. So energy before the reaction is the same as the energy after the reaction. So energy before the reaction is the same amount after the reaction. The reaction. Okay, so that's conservation of energy done. The next bit that I want to teach you is that when a chemical reaction happens, energy is either transferred to the surroundings or transferred from the surroundings. So let's write that bit down. When a chemical reaction does happen, energy is either sent to the surroundings or it's taken in from the surroundings. So energy is transferred to or from the surroundings. Now let's look at exothermic reactions. So let's just title it exothermic reactions. So an exothermic reaction is when energy is transferred to the surroundings. So this one over here. So we can say this is when a chemical reaction occurs and energy is sent to the surroundings, or you could say transferred. Now, because energy is transferred to the surroundings, that means the temperature of the surroundings will increase. So let's write that down. Temperature of the surroundings will increase. Now, for the exam, you will need to know examples. So I'll jot down a few examples over here. So examples. Now, your first example of exothermic reactions are neutralization reactions. Now, if you don't know what neutralization reactions are, this is when an acid reacts with a base or alkali to form salt and water. So let's just write acid, and then we can say plus base gives me salt plus water. Another example is oxidation reactions. And your last example is combustion reactions. This is when you basically burn something by heat. So combustion reactions. Now, in terms of everyday uses, we use this in, you could say, self-heating cans and hand warmers. Everyday uses equals self-heating cans, and you can also say hand warmers. So that's exothermic reactions done. Now we need to look at endothermic reactions. So let's put that as the title now. Endothermic reactions. Now we said exothermic reaction is when energy is transferred to the surroundings. So this is the opposite. So energy is taken in from the surroundings. So let's say energy is taken in from the surroundings. And if energy is taken in from the surroundings, that means the temperature of the surroundings, because energy is leaving, that means temperature of the surroundings will decrease. So let's write that down. Temperature of the surroundings will decrease. Now again, like exothermic reactions, you will need to know a few examples. So let's jot down a few examples. Now your first example is thermal decomposition reactions. So thermal decomposition reactions. This is when a compound breaks down to form two or more substances when it's heated. Your next one, you could say, is the reaction of citric acid and sodium hydrogen carbonate. So that's another example, but I won't write that down as thermal decomposition is the main one. Now, in terms of everyday uses, this is stuff like, you could say, ice packs. And why do you use ice packs? To treat sports injuries, you can say. Now, in future videos, I will be looking at the endothermic and exothermic reaction profiles. But that's for today's video. I hope to see you next time.